Alright, this video goes over trapezoids, isosceles trapezoids, and kites. You're going to fill this out in your foldable. The first part we're going to talk about is in the vocabulary tab. So look for the vocabulary tab in your foldable. So the one that has this. And we didn't go over the last section, which was parts of a trapezoid. Alright, so let's draw a trapezoid. So a trapezoid has two parallel sides. Boop, boop. All right, the two parallel sides are called your bases. So this is a base, and this is a base. Okay, so there's your two bases. If we draw a line parallel to those bases that goes halfway through, we call that the median of the trapezoid. So it goes halfway through. So those two pieces are congruent. These two segments are congruent. All right, and that's called the median of your trapezoid. The other thing we need to talk about the trapezoids, let's draw another one. Two parallel sides. Two sides that are not parallel. That is not very straight. That is not much better. Okay. These two angles together. Okay, so these two, and you might want to use a colored pencil to color that in. That's a set of base angles. And then with a different color, this is another set of base angles. Base angles share a base. All right, so I would make that source of color some sort of code so that you can see that better. So base angles share a base. And again, a base is either one of the parallel sides of a trapezoid. So now we're going to go over specific properties of the trapezoid and isosceles trapezoid. So make sure you're on now the trapezoid tab, and you're going to write these notes on there. All right, so first we're going to talk about a trapezoid. And a trapezoid is a quadrilateral with one set of parallel sides. If it has two sets of parallel sides, then it is a parallelogram. All right, so a trapezoid has exactly one pair of parallel sides. So boom, boom, and those are called your bases. Okay. All right, those are called your bases. And there's a special formula. Your median equals 1/2 the length of your base 1 and your base 2. So if we call this our median, all right, equals 1/2 base 1, base 2. And I can make the bottom one base 1 or the top one base 1. Just the other one has to be base 2. So you can find out that missing side by knowing those other two. So for instance, if base 1 is 10 and base 2 is 20, I can do 1/2 of 10 plus 20, which is 30, which would make the median 15. It's basically finding the average of those two lengths. Okay, so that median equals 1/2 base 1 plus base 2 added together. Now there's a special type of trapezoid called an isosceles trapezoid. It is a trapezoid in which the non-parallel parallel sides are congruent. And we could call those the legs, are congruent. So it's a pretty little trapezoid. So it still has one pair of parallel sides. So boom, boom. The median is still 1/2 base 1 plus base 2. But now the legs are congruent. So this leg is congruent to that leg. Okay, the diagonals are also congruent. And in fact, if you look, it splits it into, the diagonals split into like this triangle here is congruent to this triangle here. All right, those two triangles are congruent. So this piece is congruent to this one, and this piece is congruent to that one. And when I add this, or the whole diagonal is congruent to the other whole diagonal. Notice it does not bisect the diagonals, or the diagonals do not bisect each other. And then finally, the base angles are congruent. All right, so this angle is congruent to this one, and this angle is congruent to that one. So these first two properties that we have here are true for any trapezoid. And then these are for isosceles only. All right, so this is for isosceles. That says isosceles. Hold on, let's try that again. Isosceles trapezoids. All right. So now let's do examples using these properties. I think our first two examples are just, I guess, a regular trapezoid, and then the other two examples use isosceles trapezoids. Here are examples of using the properties of trapezoids and isosceles trapezoids. Examples 1 and 2 are trapezoids that aren't necessarily isosceles, and then 3 and 4 are isosceles trapezoids. So examples 1 and 2 don't deal with isosceles trapezoids, so we're saying those legs are not congruent. And one property that's left off of that list above that I think is kind of important is talking about if I have a trapezoid, so let's go draw one over here. Okay, if I look, let's call this A, B. So if I look at these two angles, angle A and angle B, when I add those two angles, so I call it the upper base and the lower base, when I add those two angles, they are going to be supplementary. Okay, those two angles together are going to be supplementary. Just like this angle and this angle are also going to be supplementary. We'll call that C and D. So the measure of angle C plus the measure of angle D, also supplementary. So one has to be top, one has to be on bottom, and they share a leg. And if that's the case, then those angles will be supplementary. So that's important for example 1. So I'm not sure why they left it off the list, but we'll talk about it there. Hopefully you had room to write that example over there. All right, so if I look at these two angles, if I have the 12x plus 3, and I add it to the other angle, the 13x plus 2, those two angles are supplementary. One's on top base, one's on the bottom base, and they share a leg. When I add those two things, it's going to equal 180. So I'm going to Solve this by combining like terms. 12 and 13 is 25. 3 and 2 is 5. And then I'm just going to subtract 5 and then divide by 25. So subtract 5, 25x equals 175, and then divide by 25. In this case, x has to be 407. Okay, so what's important with example 1 is it is showing you that when I add a top base angle to its opposite, I hate to say the word opposite. They share a leg, one's on top, one's on bottom, they're on the bases. When you add this together, it equals 180. All right, example 2. AB equals 7y plus 6. I'm going to label that. EF equals 5y minus 3. And I'm assuming, and I probably shouldn't, but I'm going to assume that's a median. Okay, they don't mark it as a median. Normally when they have marked a median, they'll say, hey, these two are congruent, and those two, or they'll say it's the median. And in this example, they should have. And this is y minus 2. So, your median always equals 1/2 base 1, y minus 2, plus base 2, 7y plus 6. So here we go. I don't know why they had to make this one so complicated, but we're going to go with it. Okay, so I'm going to do 5y minus 3 equals 1/2. Let's see, combine like terms. 8y. And then negative 2 plus 6 is 4. Then I'm going to distribute a half. So I'm going to have 5y minus 3. 1/2 of 8 is 4. 1/2 of 4 is 2. Subtract 4y from both sides. And I get y minus 3 equals 2. And just add 3. So y equals 5. Okay, so my median is always 1/2 base 1 plus base 2. Okay, so again, if I knew the base 1 was 10 and base 2 was 20, okay, so the top was 10, the bottom was 20. 10 plus 20 is 30. Half of that is 15, so that would make my median 15. And in this case, they had you write an equation. So the median was 5y minus 3. It's still 1/2 those two added together. So still 1/2 y minus 2 plus 7y plus 6. And I solved that equation. All right, examples 3 and 4 are isosceles. So done is an isosceles trapezoid. The measure of angle E to D to O is 110. The measure of angle D to E to N is 15x minus 5. Find the value of x. So again, one is the top base angle, one's a bottom base angle on the same leg. So they're going to be supplementary. Okay, so I'm going to solve this equation. 15x plus negative 5 plus 10 is 105. Right, subtract 105 from both sides. And you get 15x equals I gotta put that in the calculator. I'm not gonna lie to you. I think it's 75, but I'm gonna double check. Oh my goodness. Let's see. 180. Oh yeah, it's 75. All right. So 15x equals 75 divided by 15, and x is 5. Okay. One thing you should know, since this angle EDO is 110, this angle here is also 110. And so that would make this angle 70, because these two would be supplementary, the two I just wrote. And if I substitute 5, 15 times 5 is 75 minus 5 is 70 degrees, so that is 70 degrees. All right, and that works because it's isosceles. So base angles are congruent when it's isosceles. But if you look back at angle 1, you'll notice that your base angles are not necessarily congruent. You definitely have what looks like a right angle on the left-hand side. On the right-hand side is acute, and on the top is a right angle, and on the other side looks like it's obtuse. Okay. Example 4. Trap is an isosceles trapezoid, or at least that's what they're telling you. If PR is 3x minus 7, so from here to here is 3x minus 7. And TA is 20, so from here to here is 20. Find the value x. Those two are congruent, so 3x minus 7 equals 20. I'm going to add 7. I get 3x equals 27, and then divide by 3, and x is 9. All right, so those are your properties of trapezoids and isosceles trapezoids. So now we're going to talk about kites. All right, the final special quadrilateral we're going to talk about is kites. If you notice, there's not a kite tab, but if you flip to the back or flip on the back of the foldable, you'll notice I have added a kite section, so we can talk about it. A kite looks like a kite. It's a quadrilateral with 2 sets of consecutive congruent good lord, I wasn't even trying there, congruent sides. So if you look, these are consecutive and congruent, and then these are consecutive and congruent. All right, so there's 2 pair of congruent sides. Bam. There's also 1 pair of congruent angles. So if you look, this angle's congruent to this one. There's no pair of parallel sides unless the kite has turned itself into rhombus where all the angles are congruent. Sorry, all the sides are congruent. Then you could have parallel sides, but they're not necessarily parallel. In fact, when we're talking about a kite in particular and not talking about a rhombus, then we're going to talk about no parallel sides. All right, so let's look at the diagonals. This is called your main diagonal. It's normally your longest one. And this is your cross diagonal. Notice these are perpendicular to one another. All right, the diagonals are perpendicular. perpendicular. One thing I also want you to notice is that the main diagonal bisects the smaller diagonal here. Okay, so it bisects that, so those two pieces are congruent. And also, we're going to change this so it says the main diagonal bisects its angles. So it splits this angle into two congruent pieces, and it splits this angle into two congruent pieces. Right, so those angles are congruent. Okay, it has split it into equal pieces. All right, and that only the main diagonal does that. The cross diagonal does not necessarily split its angles into congruent pieces. All right, so we're going to draw one example. We're going to find some missing angles. All right, so let's say this is our kite. Oops. And that, oop. And a whoop. Oh, geez. I'm really bad at drawing these. Okay, so let's say we get this example here. Here's my kite. Let's say they tell me that this angle is 27 degrees. And let's say they tell me right, and let's say they tell me this one is 40 degrees. All right, so let's say they give me one's 27, this one's 40. In red, we're going to put the other angles we can find out. So first of all, we know these are all 90 degrees. Actually, let's just mark those with. Can we see? Oh, Lord, I'm erasing everything. Let's put this back. And then I'm going to make this a more clear 40 degrees. Okay, so we know all these are 90 because it's a kite. We know this is 27 degrees because it bisects. And we know this one is 40 degrees because that gets bisected. To find, let's say we want to find this angle here. If we look, this is a right triangle here. So I'm going to do 180 minus 90 minus 27. And I get that this angle is 63 degrees, which this one's also 63 degrees. To find this angle over here, I'm going to do 180 minus 40 minus 90, which leads us to be 50 degrees. Okay, so that's an example of where you can find missing angles of a kite. Lots of times when you find missing sides and parts of a kite, you're going to use Pythagorean theorem. All right, so those are your properties of trapezoids, isosceles trapezoids, and kites. So now your foldable should be complete.